Welcome to a lesson with Dr. Powell. Let's take a look at the first few terms of the Taylor series for e to the x plus y, okay, in two variables. Now, first of all, it's and we're going to focus near the origin, near the point 0, 0. The setup is very similar to what we do for single variable Taylor series. The first thing we just have, the first term, is simply just 0, 0 plugged in. So basically e to the 0 plus 0 is 1. So that's the very first term. The second term is simply the first derivative of this, written as a matrix, dotted with, now instead of h and k, we actually do x and y, kind of like x minus 0 and y minus 0. You looked at the derivation of this, that's really all it is. So in some sense, we just need to write out what this is in terms of both. And you'll notice that you actually just get e to the, I think it's, but then you plug in, remember, right? Okay, yes. But then we're plugging in, and in this part, we're plugging in x equals 0 and y equals 0. Now, in this case, we're replacing h and k with these things, and h and k were constants in the derivation of t. So really, we don't plug in 0, 0 for this. This is actually the x and y that actually appear in the Taylor series. We only plug x equals 0 and y equals 0 into this part right here, part of the matrix. So basically, we have e to the 0 plus 0. Let's see, and e to the 0 plus 0. And that's because, see, the partial of this with respect to x is simply e to the x plus y, but times the derivative of the inside, which is just 1. And the same thing for y. And then you're just plugging in 0, 0. So this part really just, this matrix is just a 1, 1. So you could think like a first degree approximation Taylor series for this is simply just 1 plus x plus y. Kind of nice. Okay, that's all it is. All right, because then we're just taking a dot product of x, y, and 1, 1. That's why we get this. So that's to the first degree. Let's go just one more degree. Okay, so next, all right. Okay, so we have, okay, so we have that. Okay, so now, if now we need to be able to take the second derivative. Now in taking the second derivative here, we kind of have to be we have to be somewhat careful, right? Okay, so what we're going to be doing now on that one is, if you recall kind of what was happening here, but we're thinking of these x and y's as being constants when we kind of put them in. And so what we end up getting, so when we take a derivative, we're really treating these as constant values. So we're just taking the derivative of whatever comes from this part. And in that sense, we can even just remember what this was in this case, even from the last video, if you want to. It was like along the lines of like fxx x squared plus, and it was all over 2, let's see, 2 fxy xy, and then plus fyy y squared. Okay, yeah, and that's basically what it is. Yeah, that would be what the second degree term ended up being. And you can get that, and we can get this by simply thinking of fx. So if you revert it back to h and k, thinking these as constants, so you don't confuse them and think they're x and y and then do a product rule. Please don't do that. So if you did that and you applied this, so basically what you do, you take a derivative with respect to x, and then you add, because then you multiply this by x, or h, say, multiply it by h, and then you do the same thing multiplying by k, taking the derivative of the same thing here with respect to, let's see, that's supposed to be an x, and then with respect to y, hfx plus kfy. You would get the exact same setup here. You'd end up getting this. You could just check it, but if you want, or just believe it, or take it as a formula. Just kind of think about this as kind of coming from the binomial expansion, if you will, or kind of like squaring something. It pops out the same way. So, and anyways, so in here, looking at fxx, so we take the derivative of this with respect to x twice, and honestly, we get the exact same thing every time. And so this really is going to be e to the x plus y, but we're plugging in 0, 0. Just kind of keep that in mind. So this symbol really means we're plugging in 0, 0 here for this one, but not into that x squared, just in here, please. Okay, now in here, you do the same thing. Actually, this partial, this is a nice example because this partial, all the partials are all the exact same, e to the x plus y. Okay, so you're plugging in 0, 0 in each of these each time. And so basically, if you evaluate these, you're always going to get a 1. So in this particular case, so you end up getting, for that particular term, you end up getting, and let me just write it out right here. Let's see, you end up getting plus, and then see 1 times x squared, it's all over 2, plus 2 times 1 times xy times plus 1 times y squared. So really, that's it. Pretty, okay, so this is the quadratic approximation for e to the x plus y in terms of x and y. In fact, you know what, you might actually see some kind of similarity. If you take the Taylor series for e to the x plus y, just think about what it is: 1 plus, and just kind of think about this as kind of circle plus and circle squared over 2 plus circle cubed over 3 factorial. You'll actually notice the same thing kind of happening. You put an x plus y and an x plus y quantity squared. Hey, we got that. Oh, wow, it's the same thing. Well, this was a pretty simple example where we could use a Taylor series. But normally, often you can't do this. However, when you can, why bother using the multivariable Taylor series when you can just use the single variable and just plug in? You'd really get the same thing. So kind of seeing this in some sense, you could think of, we could actually write down the third degree fairly quickly. If we use Pascal's triangle, we could think of this plus 3x squared y plus 3xy squared plus y cubed all over 3 factorial, which is 6. Okay, we just wrote out the next degree up. So the degree 3 part we wrote up for the Taylor series, and then it keeps on going. Okay, so this is a Taylor series for e to the x plus y, at least the beginning of it, and we just kind of wrote out the first few terms. Thanks for watching.